In this video, we'll discuss how to name alkanes, in specific the chained alkanes. Remember that alkanes are singly bonded hydrocarbons between carbon and a carbon. They're single bonds. And within the alkanes, or these saturated hydrocarbons, there are chained, branch, and cycloalkanes, as shown here in this image. The chained ones are this long string of carbon and hydrogen, whereas the branched ones are the ones that are, just like as it says, branched. There are kind of this berry that kind of sticks out from the main stem, and the cycloalkane, as shown in the image, is in a circular format. Now, the chained alkanes have their own specific name. So do these guys, but the one we're going to really focus on is the chained one. But now, before we go into just dive into naming all these chains, you do have to look in the reference sheet, and in the reference sheet, you should see a table that looks like this. These are all the prefixes that indicate how many carbon atoms are in an organic molecule. For example, this right here image has 1, 2, 3, 4, 5. It has 5 carbons. So here, based on the number of carbons, 1, 2, 3, 4, 5, it should start with the pent. And what is it going to be called? It's actually pentane. Anes referring to the alkanes, and so pentane. We utilize what is called the International Union of Pure and Applied Chemistry Nomenclature. Now, that's a handful of words, so we say IUPAC. So you see IUPAC. Okay. And this nomenclature is adapted by lots of chemists. And so this is something that we utilize sort of like as a source of to name a particular compound. We can name a compound representing your name. Say your name was Ellen, and we can say, hey, I created this compound and this name is Ellen. The problem is, well, when you have so many names, it's really challenging to know what is what. So the chemists came up with a universal name, and this is the IUPAC name, a very much accepted name. In the IUPAC name for alkanes, something that has 1 carbon and hydrogen, that would be considered a methane. Take a look at ethane. So 2 carbons, and so we look at the prefix eth, and then you write the word ane or ane. And propane would be something with how many carbons then? Yeah, it has 3 carbons. What would this one be? This one has 1, 2, 3, 4. So that would be butane. So butane. So let's write that down. Butane. Now here I want to introduce you to other portion of the structure of particularly the alkanes, the chained alkane. So methane has 1 carbon and 4 hydrogen around it. If you were to draw the Lewis structure, we have a carbon in the middle, and then we'll have hydrogen all surrounded by that carbon. And so there's 4 around it. The condensed structure, we call it the condensed structure, it is condensed. The Lewis structure sort of like squished in together. And what is being squished in together is the hydrogens that's squished in together. For this one, it would look like this, CH3. There's also what is called a line angle structure. Their line angle structure for methane, there isn't one, so I'm going to just draw a dash through and then just write not applicable. For ethane, however, here's the Lewis structure. It's got 2 carbons, ethane, eth, right? And the condensed structure is CH3 and CH3. So it's taking all of these hydrogens into consideration that is attached to this carbon. And all of these guys are attached to the second carbon. So hence why on the second carbon, CH3. What is a line angle structure? So line angle structure really is just lines. And what do they look like for an ethane? It will look like this. Well, what's the difference from the one on the top and the bottom? Well, at the top, it means not applicable. For here, imagine every corner of that line has a carbon. So if I were to sort of manipulate this, such as, so say if it was like this, that means every corner here, this dot I have written is representing C. And we're just imagining that there is a hydrogen that goes around it. And so hence the line. Let's do another one, propane, okay? So first, let's draw the Lewis structure. Propane has 3 carbons. So I'm going to go ahead and draw it in chain, C, C, C. Now I'm going to add all of the hydrogens around it too, so that these carbons will have a total of 4 bonds. So carbons are connected to each other, and then now they have to be attached to the hydrogen. And since their hydrocarbons are alkanes, it is not unsaturated. It doesn't have a double bond. They're all singly bonded. So the Lewis structure will look like this. Why would it look like this? How did you know to put 2 hydrogens here and 3 here? That's because if I look at this carbon, it needs 3 more hydrogens in order for it to fulfill the 4 bonds around the carbons. So here's 1, 2, 3, and the 4th bond, covalent bond. So hence I only need 3 hydrogens. For this carbon, it's already attached to 2 carbons in a single bond. So we just need that hydrogen and this hydrogen to make it a total of 4 bonds. 1, 2, 3, 4. So same for here, it's CH3 since there are 3 here. Now we're going to draw the condensed structure. How do we go about this condensed structure? We're going to first write CH3, that's representing the one on the left. Then over here, it's CH, not 3, but 2, because a carbon is attached to only 2 hydrogen. And then lastly, CH3. That's my condensed structure. Let's go into the line angle structure. In a line angle structure, we had said that every corner represents a carbon. So because there are 3 carbons here, we're going to draw it like this, a little mountain, because carbon, 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 C, C, C. So this is it. That's all it is. Now, say you drew it like this, right? I mean, wouldn't this every corner be a carbon too? Yes. So either way, whether you drew it up, down, or down, up, it would be the same thing. All right, so what about the molecular formula? You're just going to count how many carbons there are. So that's C3, and then count how many hydrogens there are. So there are 8, C3H8. By just looking at Lewis structure or the condensed structure, you could kind of determine how many hydrogens there are. Let's do a butane. First, draw the line angle structure, then let's come into the molecular formula. So for butane, there are 4 carbons. So I'm going to go ahead and draw 1, 2, 3, 4, right? Every corner is a carbon, 1, 2, 3, 4. And butane, molecular formula, there it is C4, since it has 4 carbons. And you count all the hydrogens around it. So 3, 5, 7, 10. So H10. Why don't you try the pentane and then come back and check? So here is the pentane. There are 5 carbons, and you can see the line angle structure. 1 corner, 2, 3, 4, 5 corners. So there are 5 corners. Pentane, referring to a number of carbons here, 5. Okay, so we're going to try a learning check. I'll do one with you, and then you'll try the rest, and then come back for the key. Hexane. So here's my hexane. Okay, hex means the carbon number is 6. So let's go ahead and draw the Lewis structure, or this expanded structure. 1, 6. And I'll draw the necessary hydrogens around it so that it will have 4 bonds around each carbon. Let me connect them by single bond first. You can see how these guys, these hexane and then heptane, they just add in one more carbon afterwards, right? The condensed structure. So very first carbon, that's CH3. I'm referring to this one right here. This one right here. The next one is CH2. Again, CH2, CH2, CH2. So that's 1, 2, 3, 4, 1, 2, 3, 4. Okay, and the last one, CH3. That's my condensed structure. Now for the Lewis structure, we need to go draw corner to corner. I always like going up first instead of down. And go 1, 2, 3, 4, 5, 6. Okay, there are 6 corners. 1, 2, 3, 4, 5, 6. So this is the line angle structure, and the molecular formula is C6, since there are 6 carbons, and 8, 11, 14. So H14. So if you count all the hydrogen, it should be 14. Now you're going to go ahead and try for the heptane and the octane. I mean, it's just getting bigger, so you might need a little more room, but just try it and then come back and check this video. So you can see this pattern going. C6, H14, and then the next level up, it's H16 and H18. You see the 2 hydrogen has been added every layer that you add a carbon. And same for line. All of these guys, you'll see another carbon adding with 2 hydrogens, okay, for all of these. And so this is how you name and chained alkanes, okay? And here's a key for the last learning check.